Lesson 5-14.5 is on applications of right triangles. We're going to use the calculator to approximate the function values. We're going to find angles using the inverse function. We're going to talk about sig figs, or significant digits. We're going to solve triangles, and we're going to use applications of right triangle trigonometry. Because calculators differ among makes and models, students should always consult their owner's manual for specific information concerning their use. When evaluating trig functions of angles given in degrees, it's a common error to use the incorrect mode. Make sure you are in degree mode, not radian mode. Okay, use a calculator to approximate the value of each of these trig functions. So let's get out our calculators. And for this first one, notice we are in degree mode. You can see that. For this first one, we would press sine 54 degrees, 12 minutes, close parentheses, equals, and our answer is 0.8110. Second one, it says the secant. All right, so what we would have to do is press the secant is related to cosine, so we would press the cosine 32.662, close parentheses. And now if we want the secant, it's the reciprocal of that, so we would press the x to the negative 1 key, and we get 1.1878. The last one is the tangent of negative 321 degrees. So on our calculator, tangent negative 321 degrees, and we get 0.80978. So that's how you do these. There's a couple more I'd like to practice. I'd like to practice on this cotangent one here. Remember, cotangent is related to the tangent. So we would press the tangent of 51.4283, and we get that. But then if we take the reciprocal of it, that is the cotangent, 1.797. Same would be true for this secant problem that you see here. So to find the secant, secant is related to the cosine, so we would press cosine 97.977, okay, and we get negative 0.38138. Press the reciprocal key, and it's negative 7.2. I think all the rest of these you could probably do pretty easily. Finding values using inverse functions. We have used a calculator to find trig function values of angles. This process can be reversed using inverse functions. Inverse functions are noted by using -1 as a superscript. The inverse of f is f to the -1. Our angles are going to be between 0 and 90 degrees. Here's a clue when to figure out when should use the function and when to use the inverse function. If you are, oops, that's not a very good letter. If you are looking for an angle, then use inverse. Okay? If you are looking for a side or a ratio, use the function. And that's a good way to tell the difference between the two. So, here it says that the sine of the angle is 0.71533. So we're looking for the angle. Here's how we would do it on our calculator. We would press shift sine. Notice it says sine -1, and then we'd press 0.715 5.332, and it tells us that that is a 45.6 degree angle. Secant of theta is this. Now, in this case, it's a little bit more difficult because the first thing we have to do is change this to the cosine. Remember that the secant is the cosine, is the reciprocal of the cosine, so we have to take the reciprocal of 1.21112. So our first step is to press second function cosine, and then we can press 1.21112 to the -1, right? Because we want the reciprocal of that, and we get a 34.34 degree angle. Next one. So here we've got the sine. So we would press shift sine 0.81815, and we get 50.9 degrees. Secant, which is the reciprocal of the cosine, so shift cosine, and then 1.05452829 reciprocal is 18 degrees, 18.54 degrees. Okay. A significant digit is one that is obtained by actual measurement. A number that represents the results of counting is an exact value. Most values of trig functions are approximation. All measurements are approximation. It says virtually all, but all of them are approximations. So we need to know about significant digits. When adding and subtracting, round the last digit so that you keep the rightmost column in which all the numbers have a significant digit. So what that means is if you have a column of numbers here, okay, and let's say the decimal point is right here. When we add these up, notice these two right here are missing that last place value. So we would round so that this is our last place right here. For multiplying, make sure that you have the number of sig digits. So if you have this times this, 2 digits times 3 digits, your answer will have 3 significant digits in it. For powers and roots, round the answer so that it has the same number of sig digits as the numbers whose power or root you are finding. So if you have 1, 1, 1 to the third, then your answer will have 3 significant digits. That's basically how to figure sig digits. If you're measuring to the nearest degree, use 2. 10 minutes, use 3. Minute, use 4. Tenth of a minute, use 5 sig digits. Okay, how do you solve triangles? To solve a triangle means to get all 6 parts of that triangle. Let's look at this one, and let's use our calculator to solve this triangle. Okay, the first thing we can do is, if you notice, we're given this angle. Because of that, we can find sides A and B. Because the sine of a 40.3 degree angle is A over 14.8. The cosine of a 40.3 degree angle is B over 14.8. Now, to get the A all alone, we would multiply both sides by 14.8. And so on our calculator, we would press 14.8 times sine 14.3, oops, 14.8 times sine 40.3, and we get 9.572, 9.6. Okay? For side B, multiply both sides by 14.8. Notice the 14.8s cancel. So we would press on our calculator 14.8 times cosine 40.3, and we get 11.3. Okay? Angle C we know is 90 degrees. Angle B must be 49.7 degrees because these two have to add up to 90 degrees. So we have just solved all 6 parts of this triangle. Let's look at another one. Oops, we don't need the calculator yet. Okay, so angle B, we can find that right away. Angle B is 90 minus 34.30. Side A, well, we're given the sine of a 34-degree 30-minute is A over 12.7, and the cosine of a 34-degree 30-minute is B over 12.7. Multiply both sides by 12.7, and that will be what A and B are. Okay, so let's get out our calculator, and let's solve those 3. So the first one is 90 minus 34 degrees 30 minutes, and you get 55 degrees. Well, let's change it to degrees, minutes, seconds. 55 degrees 30 minutes. Okay. Then A on our calculator will be 12.7 times sine 34 degrees 30 minutes. Oops, clear. I forgot to do 12.7 times sine 34 degrees 30 minutes. And we get 7.19. So A is 7.19. And then B will be 12.7 times cosine 34 degrees 30 minutes is 10.5. So now we've got all 6 parts. Next one. This time we're going to solve a triangle, but we're only given 2 of the sides. Okay? So what we can do is, first of all, find angle A. Angle A, capital letter A, the, let's see, cosine -1 of A is opposite, or is adjacent, 23.1 over 42.5. Once we get that, we can figure out what B is from the 90 minus whatever we get for A. And then for this side A will be the square root of 42.5 squared minus the hypotenuse minus 23.1 squared. Okay. So let's get out our calculator. Cosine -1 of 23.1 divided by 42.5, close parentheses, is 57.075 degrees. Let's say 57.1 degrees. So A is 57.1 degrees, which makes B 32.9 degrees. And then A, we'll just calculate here. Square root 42.5 squared minus 23.1 squared is 35.7. 35.7. So there's our missing parts of that triangle. All right. This one is a little bit different because it has us doing the opposite side. So in this case, we would say sine -1 of A is 29.43 over 53.58. And then side B, well, angle B will be just 90 minus that. And then side B will be the square root of 53.58 squared minus 29.43 squared. So let's break out the calculator. For the first one, we would press Shift Sine 29.43 divided by 53.58. And we get 33.3 degrees. 33.32 degrees, let's say. So this must be 56.68 degrees, because they have to add up to 90. And then for our other one, we'll just press it on our calculator. Square root 53.58 squared minus 29.43 squared is, and so B is 44.77. All right. Next one. Angle of elevation is from the horizon looking up. Angle of depression is from the horizon looking down. Let's look at this example here. It says, find the angle of elevation of the sun. Okay, so we've got the problem set up here. Notice this is the opposite side. This is the adjacent side. So we would say the tangent -1, because we're looking for the angle, that's tangent -1, of 40, or opposite, which is 35.28 over 40.45. So let's break out the calculator. That's the only side that they want us to do. They don't want us to get all 6 sides. So shift tangent -1 of 35.28 divided by 40.45 is 41 degrees, 41.09 degrees. Okay, next one. Anna Pott knows when she stands 123 from the base of a flagpole, the angle of elevation to the top is 26.40 degrees. If her eyes are 5.3 feet above the ground, find the height of the flagpole. Okay. So the flagpole is the opposite side. This is the adjacent side. So the tangent, 26 degrees 40 minutes, is opposite over 123. Or multiply both sides by 123. We'll find the opposite side. So 123 times tangent 26 degrees 40 minutes is 61.77 feet plus 5.3 gives us 67.1 feet. That's how tall the flagpole is. Next one. Okay, the length of a shadow of a building 34.09 meters tall is 37.62 meters. So we're looking for the angle. So the tangent, -1, opposite side is 34.09 over adjacent side 37.62. Okay, well, let's find out what that is. Tangent, -1 of, I'm going to use the fraction key this time, 34.09 over 37.62, oops, is, delete, backspace, okay, is 42.18 degrees. All right, next one. Distance across a lake. To find the distance RS across the lake, a surveyor lays out RT, which is 53.1 meters, and angle T is 32 degrees 10 minutes, and angle S is 57 degrees 50 minutes. Find R to S. Well, you don't need this piece of information because you can find it. Hold everything. Yeah, you can find it because this is a right angle. You can find it from this information because the opposite side, which is what you're looking for, is part of the tangent. The tangent of a 32 degree 10 minutes is opposite side over 53.1. Multiply both sides by 53.1. So we will take on our calculator 53.1 times tangent 32 degrees 10 minutes is 33.4 meters. 4 meters across the lake. That's not a very big lake. Wouldn't catch many fish in that thing. Okay, next one. This is actually how they measured the height of Mount Everest. The highest mountain peak in the world is Mount Everest, located in the Himalayas. The height of this enormous mountain was determined in 1856 by surveyors using trigonometry. This difficult measurement had to be done from a great distance. At an altitude of 14,545 feet on a different mountain, the straight line distance to the peak is 27.0134 miles, and its angle of elevation is 5.82 degrees. Find the height of Mount Everest. Okay, so there's two parts to the problem. The first part is to determine what this is, but then we have to add 14,545 feet to it. The other thing that you'll notice is this 27 5,00134 is in miles. So we have to change that miles into feet because we want this elevation to be in feet. Okay, so we know this angle, and the opposite side compared to the hypotenuse is the sine. The sine of 5.82 is opposite side, which is what we're looking for, over 27.0134 times 5,280. To get the opposite all alone, we're going to multiply both sides by this. So let's break out the calc, and then we have to remember to add this 14,545 to it. Okay, so 27.0134 times 5,280, that tells us how many feet are in 27 miles, times the sine of 5.82 degrees is 14,463 feet plus 14,545 is, Mount Everest would be 29,008 feet tall. 29,008, which is reasonably close. They didn't get the angle with enough sig digits so that we could figure out exactly how tall Mount Everest is. I think it's 29,054 feet, but I'm not sure about that. And I believe that is our last problem. So if you have any questions, give me a call.